Welcome to our today's lesson, and I am your tutor, Mr. Ngatia. And today I just want to look at how the area under a curve can get estimated. So in this regard, you are supposed to first understand as a student that area approximation can actually be able to get discussed in detail in as far as the following methods are concerned. Number one, there's a method that we call trapezoidal rule. That one is always the first method that can be used to estimate the area that actually falls under a curve. And again, someone can also talk about the mid-ordinate rule. That one can as well be able to get used in estimating the area under a curve. And as well, the last method is what we call the integration method. So we can apply the trapezoidal rule, the mid-ordinate rule, or the integration method to be able to estimate the area under a curve. And you should note this. This mid-ordinate rule gets taken to be the most accurate when compared to the trapezoidal rule. So most mathematicians will prefer using the mid-ordinate rule to estimate the area under a curve because it tends to become more accurate. So that is actually to say, when I use the mid-ordinate rule and again use what we call the integration method, these two must have a very closer resemblance in as far as the answer you are supposed to get is concerned. The trapezoidal rule tends to be a bit not so accurate, so it tends to get left out in as far as our discussions in mathematics are concerned. Now I'm going to use this question to be able to explain these methods. Number one, we have a question that came in 2003. It was actually paper 1, number 20, if I'm not wrong. Good. And if you look at this question, it is actually able to read, the diagram below is a sketch of the curve y is equals to x squared plus 5. That is the curve that has actually been able to get sketched. So the question reads again, part A, Roman 1, use the mid-ordinate rule with 6 strips to estimate the area enclosed by the curve, the x-axis, the y-axis, and the line x is equals to 3. Part 2 of actually this question reads, calculate the same area using the integration method. Then part B says, assuming the area calculated in A2 is exact, calculate the percentage error made when the mid-ordinate rule is used. Now, I'm first going to use the trapezoidal rule, then I'll use the mid-ordinate rule, then I'll use the integration method, so that in the process of answering this question, I can be able to explain to you how all these methods can be used to actually estimate the area that falls under a curve. Good. So I'll first make a sketch of this curve in my working here. This can be the sketch of the curve. That can be the sketch of the curve. As a rough sketch is the x-axis. Then we have the y-axis. Good. So after I'm done with that part, this is the curve. Good. So the curve reads y is equals to x squared plus 5. Now, if I look at this curve, they are trying to tell us that we actually get the area that falls under this curve. So if I may want to make some sketches for you to understand what I'm trying to say, I can be able to draw a line that actually drops and actually meets the x-axis. And in that case, if a line gets drawn in this regard, it can fall somewhere in front of 3. But now they're telling us to get the area enclosed, by the curve, the x-axis and the y-axis, and as well line x is equals to 3. So the area enclosed by this curve, okay, and then the x-axis, the y-axis, and x is equals to 3. So I'm going to drop a line here. Let me say this is 3 to be precise, and I may extend this, no problem. So this one becomes the curve. So we want to get the area that gets enclosed by this curve, the x-axis, the y-axis, and x is equals to 3. You can see that. That is the curve that gets actually talked about. The diagram is very important for you to be able actually to understand what we are really talking about. So the area under this curve, the x-axis, the y-axis, and x is equals to 3. Great. Now, if we are using the trapezoidal rule, you should note this. We are supposed to actually draw strips of this sort. And before I can even commence on drawing the strips, let me go back to the question and see how many strips are we supposed to use in as far as calculating the area that falls under this curve is concerned. The question says, using the mid-ordinate rule with 6 strips, and because I want to use the trapezoidal rule, for the purposes of accuracy, I will as well be able to use 6 strips in as far as the trapezoidal rule is concerned, also to know how much in terms of the area will fall under this curve. So I'm going to draw 6 strips. So I have 1, I have 2, I have 3, I have 4. So look at that. So I have the first strip, the second strip, I can have the third strip here, I can have the fourth strip, the fifth strip, and the sixth strip. So I'm using first the trapezoidal rule. The question says use the mid-ordinate rule, but I want to use first the trapezoidal rule to know what am I going to get in as far as the area under this curve is concerned. Now what I'm going to do here, I'm first going to draw a table. The table will have the x values, okay? The table will have the y values. For that matter, I'll be able to draw something of this sort. Note this. If the question says use the trapezoidal rule with 6 strips to calculate the area that falls under this curve, please start counting from this strip. Look at that. So in other words, if you're using 6 strips, you're supposed to have 7 values of x. Let me see. The first value of x, the second value, the third value, the fourth value, the fifth value, the sixth value, and the seventh. So if they say use trapezoidal rule with 6 strips, ensure you begin from this point and then have 7 values of x. The first value of x, the second value of x, the y value of x. So 1, 2, 3, 4, 5, 6, 7. The first, the second, the y, the third one now for that matter. Then the fourth, the fifth, the sixth, and the seventh. Now I'm going actually to have this. So I'll have x0. Why? Because the first value here is actually 0. Again, the point, because they said between the x-axis, this one, look at that. Then the y-axis. This line is called y-axis, or they can actually be able to say x is equals to 0. So y-axis or x is equals to 0. So here we have 0. So we have x0 as the first value of x. Then we have what we call x1. Good. We have x2. We have x3. We have x4. Let me just even put them here. So we have x0. Then we have x1. We have x2. We have x3. We have x4. We have x5. And we have x6. So x0, x1, x2, x3, x4, x5, x6. 7 strips. But now 6 strips. I said if they say 6 strips, ensure you have 6 values of x with an additional value of x. So you have 7 values of x at the end of the day. So x1, x2, we have x3, we have x4, we have x5, we have x6. So x0 to x6, x0 to x6. 6 strips but 7 values of x. 6 strips but 7 values of x. Now after that, you can come here and say, how do I get y? The curve reads y is equals to x squared plus 5. So x squared plus 5. Now in this case, I will only be able to get the value of what? Of x. If I come back here, the curve reads, just look at this, y is equals to x squared plus 5. Now ask yourself, the area and the curve has to be obtained in the range of values of x that are supposed to actually get given. Now in this case here, the values of x range from x0 to x6. x0 has the value of x as 0. x6 has the value of x as 3. If you can look at that. Yes. So we have 0 and 3. So you have the range x is equals to 0, and of course again x is equals to 3. Now we are supposed to get the height. What do I mean when I say height? Look at this. We want to see what is this. What is this? What is this? Because the height must be uniform. Good. Because if this is a trapezium, I can be able to draw something of that sort. So if this is the height, this also gets to that point of being the height. This one becomes the hypotenuse. This one becomes the base. This can form a triangle. Then you have the rectangle part of it. Look at that. So if this is the height, this is also the height of the trapezium. If I use this one as my trapezium. Again this one becomes the height. This is going to be the same length. Now the height. Then you have the longer side of the trapezium, the shorter side of the trapezium, the hypotenuse of the triangle at the end part of that. Now I'm going to come here and say, for me to get this height, what do I need to do? I'm going to say the difference between the two lengths. I'll say 3 minus 0 over. How many strips am I using? I'm using 6 strips. 1, 2, 3, 4, 5, 6. You see? So between x0 and x6, we have 6 strips. These 6 strips are able to get divided, and in that case, they can give us a shape of this type. And in this regard, we are supposed to say the last value of x3, the first value of x0, is subtract the 2, then divide by the number of strips, we get the height. So the last value, the first value, divided by the number of strips, you can get the height, or 1 strip. So we divide by 6, we are going to have 3 over 6, and this gives us 0.5. So that means this is 0.5, 0.5, 0.5, 0.5, 0.5, 0.5. So 0.5, 0.5 times 6, it gives you 3 as the length of this curve. And as far as the x-axis is concerned, so 1, 2, 3, 4, 5, 6. Good. So 6 times 0.5, it gives you 3. Okay. So this gives us now the h, 0.5. Now, what do you do here next? What are the values of x in this case? I will always pick the first value of x as 0. I start from the beginning. So I'll say the x0 is 0. Then from x0, if I add 0.5, what do I get? I get 0.5. So 0, then plus 0.5, I'll get 0.5. Then again plus 0.5, I'll get 1.0. Then add 0.5, 1.5. Then I'll get 2.0, 2.5, 3.0. so that from the start to the end must resemble what you have in your table. So from 0 to 3 with a difference of 0.5 as the height. Now we shall replace the values of x in this equation of the curve to get the corresponding values of y. So I'll say the value of x here, the value of x here is 0. If I replace it here, then add 5, what will be the value of y? So I'll say 0 squared, then plus 5. That gives me 5. So I'm going to write here 5. Okay, I'll do the same for this. I'll come here and say 0.5 squared plus 5. What do I get? So 0.5 squared, then I say plus 5. That gives me 5.25. Then x2, I'll say 1 squared, then plus 5. I get 6. x3, 1.5 squared, so I'll say 1.5 squared, then plus 5. That gives me 7.25. I'll come here, x4, 2. So 2 squared plus 5, that gives me 9. Then 2.5, so I'll say 2.5 squared plus 5, that gives me 11.25. Then lastly, I have 3 squared, then plus 5, that gives me 14. Good. I'm done with getting the corresponding values of y when the values of x are actually given. Now, when I'm done with that part, I'm going to actually say, if this was 0, as must my x0, then x1 here, with a difference of 0.5, will obviously become 0.5. If I add another 0.5, I get this as 1.0. If I add another 0.5, I get 1.5. You see? So if the x is 1.0, what is the height? This is the height, the height, the height, the height. So in that case, I'm going to get actually the corresponding values here. That will become now the value of y, the value of y, look at that, y, 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 y. Good. So if I take it as this, it looks like actually the height, but the real height is this. So students confuse and actually take this to be the height. No, this is the y, this is the y. Look at that. The first y, the second y, the third y, the fourth y, the fifth y, the sixth y, and the seventh y. So I'm going to have y0, look at that. I'm going to have y1, I'm going to have y2, I'm going to have y3, I'm going to have y4, I'm going to have y5, and I'm going to have y6. So when x is 0, what is the value of y? When x is 1, what will be the value of y? x2, y2, x3, y3, x4, y4, x5, y5, x6, y6. We've gotten those. That is to say, this is going to be our y0, is going to be our y1, our y2, our y3, our y4, our y5, our y6. Look at that. So x0, y0, x1, y1, x2, y2, x3, y3, x4, y4, x5, y5, x6, y6. I'm done. I have to come up with the formula now. I've said you have the curve. Look at the number of strips asked. Divide that into the number of strips given. 1, 2, 3, 4, 5, 6. If you're done with that one, come up with a table. Write x. Write the equation. You have to get the values of x. So x0, x1, x2, x3. Why do you begin from x0? If there are 6 strips, ensure you have 7 values of x. So how do I get 7 values of x? By having x0 as my first value, or whatever you have been given in that question. They can say between x is equals to 2 and x is equals to 3. So I have to begin from x is equals to 2. So the first value of x here will be actually 2. Just in case they say between x2 and x. Look at that. So if x is 2 and x is 3, then that means the first value of x here will be 2. You see. Now, And because we are actually beginning from y-axis, which is now x is equals to 0, then that means our first value of x will be 0. So we begin from x0, x1 up to x6. Those become 7 values of x. I've told you the first value of x is 0, the last value of x is 3. What do I get? I have to get the height. How do I get the height? The last value, the first value, divided by the number of strips asked. That gives me the height. That height means if this is 0, I have to get the second height by adding 0.5. Look at that. 0.5, 1, 1.5, 2, 2.5, 3. So it is actually to enter into that matter. Okay? And in that case, I'm going now to actually say, if x is 0, what is going to be the height? If x is 0.5, what is going to be the height? If x is 1.5, what is going to be the height? Or the y? The y. The y. The height in terms of the y-axis. Now in this case, you actually have to label it y0, y1, y2, y3, y4, y5, y6. The formula of getting the area of a trapezium as far as the trapezoidal rule is concerned reads a half h, open brackets, open again another bracket, y0 plus y last, close bracket, plus 2, open brackets again, then you say y1. It began from y0 and y last. So from y0 we have y1, then y2, then y3, then y4. Using this case, I'm going to have y0 and y6. So I'm going to say y6 instead of saying y last, because the last one is y6. So I'm going to say y0 is 1, and then y last, y6. Then plus 2. So which ones are remaining in between? We have y1, we have y2. Let me just make them clear. y1, y2, y3, y4, then y5. You see? So y1, y2, y3, y4, y5 are to be written here. So plus y5, then close bracket, then close. That is just easy. So I'm going to have a half times, what is h? Our h is 0.5. So 0.5, open brackets. What is y0? Our y0 is actually 5. So I'll have 5. Our y6 is 14. So 14, then close brackets, like that. Then we have plus 2 into y1. y1 is 5.25, you can see it there. Then y2 is 6, y3 is 7.25, y4 is 9, then y5 is 11.25. Close brackets, then close. So what is a half times 0.5? That gives us 0.25. Open brackets. What is 5 plus 14? That is 19, then plus. Then you can add all these ones, then multiply by 2. So you're going to have, which is very clear from this side, I'm going to have, okay, let me see. So I have 5.25 plus 6 plus 7.25 plus 9 plus 11.25. I get 38.75. Then I'm going to say times 2. Times 2. So the sum times 2. So times 2, I'm going to get 77.5. 77.5. Good. So I'm going to have 77.25. Great. What is the final answer? So I'll say 77.25 or 77.5 in that case. So we have 77.25. Let me just confirm the answer. 5.25 plus 6 plus 7.25 plus 9 plus 11.25. That is 38.75. Then times 2, I'll get 77.5. So it's actually 77.5. 77.5. So I have to add 19. Then plus 19. here. What do I get? 96.5. So I have 0.25, this one, into 96.5. Good. So I just multiply to open the brackets. So times 0.25. I get 24.125 as my final answer. So the area under the curve is 24.125. Then you write square units. Thank you so much for your time. Let's meet in our next video.